Typically, automatic boost transfer scheme is with traditional IDs, but in this time we will show the automatic boost transfer scheme with the PLC. In the configuration main, the sequence of operation is normal operation condition, loss of source 1, loss of both sources, and breaker to trip. We focus on show the components and the operation of the transfer system standard by PLC. The main components. We have the IMAX circuit breaker with the PR122 or 123. Furthermore, we have the closed coil, shunt trip, gear motor, bell lar, and 5 contact auxiliary. The PLC IC500 or Echo, the memory card, an adapter, the connection terminal, and the digital input and output module are the components of the standard offered. This is a demo that we use for this project. Include a PLC with 2 analogic input for simulate the undervoltage and 1 Boolean input for simulate the synchronous.
The HMI consists in 5 main pages. The index page, our project settings, where we can find every parameter and settings for the main breakers. The Mimic boost, you can see the automatic transfer in this page. We can use also the control of breaker to trip. We can go to any page of main 1, main 2, or tie. We can use also the index to go to the main 1, main 2, or tie. We lose 25. In the HMI we can see that we don't have 25 anymore. So we lose voltage. This one is open, this one closes, and this one remains closed. So we return the voltage. This one will open first, and then this closes.
We have 2 kinds of relays, one relay ANSI 25 and 2 relays ANSI 27. If we need more protection like ANSI 47, 50, 51, we can add with the wired logic. This project is shown by Carlos Ferretti's Application Engineering and Daniel Martinez Electrical Engineering by R&D. This stage is with the MNS switchgear are resistant with 1 arc protection device like a TVOC2 and 3 IMAX circuit breaker with the configuration main for the test.
Normal operation condition. During a normal operation condition, we have the main 1 closed, main 2 closed, and tie open.
The main scenario for this project will be our device for arc protector, our 3 main breakers, which are IMAX circuit breakers, our PLC with our analog inputs, and 2 Boolean inputs, and our HMI, which we can see our Mimic boost, so we can see how the automatic transfer is working. So,
loss of source 1. During this case, we're going to lose the voltage in the source 1. This will create that the 27 relay will send the signal to the PLC that there is no voltage. Therefore, the PLC will send a command to open the main one and close the tie.
First case. In our first case, we're going to lose our voltage in the main one. This will create that this one will open, this one will close, and the main two will remain closed. So we're going to simulate our voltage with an analog input. So we lose our voltage. The relay 27 sends the signal that there is no voltage. So the PLC sends a command to open the main one, closes the tie, and main 2 remain closed.
Return of source 1. During this case, the voltage in main 1 is back. The PLC reads the status, reads that there is synchronism, and then closes the main 1. This creates that there is parallelism between the 3 breakers. After an adjustable time, the tie will open.
In our case 2, the voltage returned. So with the same step with the analog input, we return our voltage. The PLC remains 10 seconds waiting for the command, and there you go. We have parallelism between the 3 main breakers, and this one will open after 10 seconds.
Return of the source 1 without synchronism. During this case, the voltage returned to the station. The PLC receives the status and checks if there is synchronism. In spite of the absence of the 25, the PLC opens the tie first, and then the main one will close.
Case 3. Suppose we don't have synchronism, and then we're gonna lose the voltage in the main one, and we're gonna see what happens in our project. So we lose 25. In the HMI we can see that we don't have 25 anymore. So we lose voltage. This one is open, this one closes, and this one remains closed. So we return the voltage. This one will open first, and then this closes.
Loss of both sources. During this case, we're going to lose the voltage in the 2 main breakers. This will create that everything will open, including the tie, leaving the loads without energy. Return of source 2 and loss of source 1. After losing both sources, we suppose that voltage in the main 2 returns. This one will create that the PLC will check the synchronism, will check the status, and then send a command to close the die and closes the main 2.
Suppose we lose both sources, which is main 1 and main 2. With the analog inputs, we lose main 1, we lose main 2, and everything is open. Open, open, open. And in our mimic boost in the HMI, we can see that everything is open. So we return main 2. We return the main voltage of the breaker number 2. Waits 10 seconds. It closes, and the tie also closes. And this one remains closed because there is no voltage in it. So we return the voltage, and closes, parallelism, and then we have normal conditions again. So this one will open after 5 seconds. suppose the user wants to make a maintenance in any breaker. Suppose we want to make the maintenance in breaker number 1. So we're gonna use our breaker to trip in the HMI. It's open, the tie closes, and well, main 2 remains closed. Suppose we return our breaker to trip. There it goes, we have parallelism, normal conditions, and then this one will open. Now we're gonna simulate the breaker to trip without synchronism. So we take out synchronism, and could you help me please? We break number 1, tie closes, main 2 remain closed, this one is open, and well, we return the breaker to trip. This one is open, and then this one is closed, so we don't create parallelism when there is no synchronism.
The TVCO2 has a light detection and current confirmation with the current sensor unit in the case of the arc flash.
This is the arc protection relay with the test light.
The installation is in the medium height of each section of switchgear, one in the bus and one more in the cable compartment, when we have barriers between cable compartment or is an arc resistant switchgear.
Our last test, we're going to simulate the arc flash for our device of arc protector. In this test, we're going to simulate the arc with a light that we have in the back part of this station. So we're going to put the light, and we're going to see that this breaker will open and this one will not close, because we don't want to transport the problem from breaker number 1 to the other breaker. So this one will remain open. So there you go, the flash. We have an alarm and it is open, and this one will not close until we reset. We put the reset in our PLC. So with this Boolean input, we're going to simulate our reset. So now it's closed because I put a reset on the failure of the arc flash.